So here we have a 4-stroke engine. And here we have a 2-stroke engine. If we observe the anatomy of these two engines, upon first glance, they seem very similar. They both have a crankcase and a crankshaft together with a connecting rod. As well as a wrist pin and a piston. They also both have a cylinder and they both operate by converting the reciprocation of the piston into the rotation of the crankshaft, which then turns the gears of the transmission and ultimately the wheels of the vehicle. But beyond these core similarities, the 4-stroke and the 2-stroke start to fundamentally diverge, resulting in two very different approaches to internal combustion. And what I want to do today is give you the only video you need to watch to get a very solid understanding of how a 4-stroke and a 2-stroke engine work. We'll also be exploring the differences, benefits, and drawbacks of each engine type, and this will then answer the question of why the 4-stroke ultimately prevailed over the 2-stroke in most applications, despite being larger, heavier, more expensive, and more complex. So let's get started with the 4-stroke. Why is it called a 4-stroke? It's because the 4-stroke engine needs 4 strokes to complete one combustion cycle. Every time the piston moves from top to bottom, or vice versa, that's 1 stroke. 1 stroke of the piston equals 180 degrees of crankshaft rotation. Now the 4 strokes are intake, compression, combustion, and exhaust. During the intake stroke, the piston travels from top to bottom, which are also known as top dead center and bottom dead center. As the piston does this, it creates an empty space or vacuum inside the cylinder. This newly created void is essentially a brief absence of air. And because we have an absence of air, we also have an absence of air pressure. In other words, we have a low air pressure inside the cylinder and atmospheric air pressure outside the cylinder. This air pressure difference cannot continue to exist, and air naturally seeks to equalize pressure everywhere. And so air, together with fuel from the outside, rushes into the cylinder and fills it with a fresh air-fuel mixture. By the time the piston reaches bottom dead center, all the air and fuel that can hope to get in have done so, and the piston now starts to move upward. As it does that, it forces the air-fuel mixture into an ever smaller space. In other words, it's compressing the air-fuel mixture, which is why this stroke is called the compression stroke. Just before the piston reaches top dead center, the spark plug fires and ignites the air-fuel mixture, which finds itself between the two electrodes of the plug. Although combustion inside an engine is often described as a bang or explosion, that isn't what's actually happening. An explosion is detonation, which is a rapid, uncontrolled process. In contrast to this, combustion is deflagration, which is a much slower, more even, and controlled process. Combustion spreads out evenly outward from the spark plug through heat transfer. The small portion of air-fuel mixture initially ignited by the spark plug heats up and ignites the next layer of the air-fuel mixture. This layer then ignites the next layer, and the process continues until all of the air-fuel mixture is burned. As the combustion flame front spreads, it rapidly raises the temperature and pressure inside the cylinder. Because the cylinder is sealed, this pressure has nowhere else to go, so it ends up pushing the piston down the cylinder with great strength. This is our combustion stroke. And of the 4 strokes, this is the only one that actually generates power. And it does so by converting the energy released by combustion into motion of the piston, which then turns the crankshaft and ultimately the wheels. By the time the piston reaches bottom dead center again, all the air-fuel mixture has been burned, and we now have exhaust gas, or the remains of combustion, inside the cylinder. As the piston moves up once again, the exhaust gases leave the cylinder and exit through the exhaust piping, catalytic converters, and mufflers out into the atmosphere. Now, if you know a bit about engines, then you've probably noticed how my explanation of the four-stroke combustion cycle fails to answer some very important questions. And these are: how do we allow air and fuel to get in during intake? How do we keep air and fuel as well as combustion energy from escaping during compression and combustion? And how do we allow exhaust gases out? Well, the answer to all of this is the same thing, and it's valves. The intake valve opens during the intake stroke to allow air and fuel into the cylinder. Both valves are closed during the compression and the combustion stroke to prevent air and fuel as well as combustion energy from escaping the cylinder. And finally, the exhaust valve opens during the exhaust stroke to allow exhaust gases to escape the cylinder. Now, the valves are operated by the camshaft, and as you can see, the camshaft has lobes on it. As the lobe contacts the rocker arm pushes onto the valve and opens it. As the lobe releases the rocker arm, the valve spring ensures that the valve returns to its